So now that we've looked at some regression techniques, let's move on to classification. We've divided our data into 4 categories: bad movies, okay movies, good movies, and excellent movies, and we run these through the decision tree regressor. And it looks like this model is only about 60% accurate, but given some of the results we've gotten before, and just considering how large and complex this data set is, I don't consider this awful, but it is important to note that it is very unreliable when precisely and accurately labeling negative samples as positive and in its ability to find all positive samples. And so now looking at feature selection in Exertree's classifier, this illustrates the predictors that it is deemed most significant. Looks like number of voted users is considerably the most significant, with about an effectively equal significance between duration and number of critics for reviews. Now, SelectKBest has determined that number of voters and movie Facebook likes seem to be the best predictors. And this coincides with some results we've seen earlier about the number of voted users. But this is interesting because this is the first time we've seen much significance assigned to the movie Facebook likes. Now, when we consider clustering, we divide our data into groups that have shared characteristics. And so we've divided our data into 4 clusters that are all segregated and grouped by similarities in their traits. And it looks like cluster 2 is by far the largest cluster here by a significant amount. And this was the one that was characterized by a low number of critics, low duration, low number of Facebook likes, and a low number of user votes. And when we run this through the decision tree, we see that this is outstandingly accurate, at least compared to some of the models we've seen before, almost 100%. Our precision recall scores are outstanding, and this looks like a great model. And when we look at the feature importance of this, it has decided that number of voted users is a very important feature, followed by number of critics for reviews and duration, which again supports observations that we had already made. So when we look at some of the discoveries we've made from regression, they yielded relatively disappointing results in terms of finding reliable and accurate model to predict movie success. We got a lot of high mean squared errors. We got a lot of low R squared, which are the type of things that we want to be really accurate. But when we use multiple regression, the results were about the same, but we did observe some multicollinearity in these models. But as we discussed earlier, this is just something that we are accepting about it. It didn't appear as if any causal relationships existed between the X variables, so it wasn't really in our interest to try addressing it. It's just something we have to accept. And we determined that the most important independent variable was number of users voted. About the same amount of importance was assigned to number of critics for reviews and duration. When we ran these through a random forest regressor, we had an outstanding mean square error of 0.12878 and an R square of 0.88458. And this is incredible. It's so impressive compared to some of the accuracies and mean squared errors and R squared values that we had received earlier. So when we look at classification, we separated the discrete values into 4 categories. And we found the first model to be about 60% accurate, but it was highly imprecise. And so this is not a model that we want to continue using further. But the Exertree's classifier did give us insight about which models were, or which variables were most significant. Number of voted users was considerably the most important predictor, just reinforcing some observations we had already made. When looking at clustering, Cluster 2 is by far the largest, with 2,264 observations, meaning most movies in our data set can be described as having a low number of critics, low duration, low Facebook likes, and low number of user votes.